The TKPROF is a tool provided by Oracle that converts Oracle trace files into a more readable form. It formats and summarizes the diagnostic information from the raw SQL trace. If you have a problem query, you can use your TKPROF to get more information. TKPROF allows you to analyze a trace file an easy way to determine where time is being spent and what query plans are being used on SQL statements. Initialization parameters required are timed_statistics, max_dump_file_size, and user_dump_dest. Timed_statistics, this enables or disables the collection of timed statistics, such as CPU and elapsed times. Max_dump_file_size, when the SQL trace facility is enabled at the instance level, every call to the server produces a text line in a file in the operating system's file format. The maximum size of these files is limited by this initialization parameter. The default is 500. User_dump_dest, this parameter must fully specify the destination for the trace file. Following commands can be run to set the parameters. Alter system set timed_statistics equals true. Alter system set user_dump_dest equals dir. Alter system set max_dump_file_size equals 500m. When the SQL trace facility is enabled for a session, Oracle generates a trace file containing statistics for traced SQL statements for that session. Oracle creates a separate trace file for each process. Enable tracing by running the following query. Alter session set SQL_trace true. To generate trace file by running the following. Alter session set SQL_trace equals true. Run your SQL query. Example. Select count, asterisk, from EMP. Alter session set SQL_trace equals false. The next step is to format trace file. The generated trace file will be located in the user_dump_dest directory. Trace file can be interpreted using TKPROF at the command prompt as follows. TKPROF trace file output file. TKPROF output file mainly has following sections. 1. SQL statement. 2. Tabular statistics, parse/execute/fetch statistics and timings. 3. Library cache information. 4. Row source operations. 5. Wait event information. Let's explore each of these sections. SQL statements. The output file generated by TKPROF contains detailed information about the SQL statements executed during the traced session. It includes statistics such as CPU time, elapsed time, disk reads, and more for each SQL statement. When tracing lots of statements at once, such as batch processes, you can quickly discard those statements which have unacceptable CPU times. It's often better to focus on those statements that are taking most of the CPU time. Inefficient statements are mostly associated with a high number of block visits. Find the problematic your SQL statement that you are interested to analyze. Tabular output. Count equals number of times each individual activity like parsed, executed, or fetched has been performed on this particular cursor. CPU equals the total CPU time in seconds for all parse, execute, or fetch calls. Elapsed equals total elapsed time in seconds for all parse, execute, or fetch calls. It is the time taken to identify and modify rows during statement execution on the server. If this value is higher than CPU time, then you should review the wait events sections in the TKPROF for the SQL to understand where the waits happened. Disk equals total number of data blocks physically read for all parse, execute, or fetch calls. Generally, it would be preferable for blocks to be read from the buffer cache rather than disk. Query equals this is logical read. Total number of buffers retrieved in consistent mode for all parse, execute, or fetch calls. Consistent read means get the block as it appeared at the beginning of our statement, using rollback data if needed to undo changes. Usually, this type of logical read is used by queries. Current equals this is logical read. Total number of buffers retrieved in current mode. Current mode means get the as it exists right now. No need of applying any rollback data, etc. Buffers are retrieved in current mode for statements such as insert, update, and delete. Rows equals total number of rows processed by the SQL statement. This total does not include rows processed by subqueries of the SQL statement. For select statements, the number of rows returned appears for the fetch step. For update, delete, and insert statements, the number of rows processed appears for the execute step. Total equals sum of all operations. Parse, number of times Oracle finds query in shared pool or creates a new plan. Execute, number of times Oracle does the work of query. It is empty for select statement. For insert, update, and delete statements, this modifies the data. For select statements, this identifies the selected rows. Fetch, number of times Oracle pulls the data back, empty for update, bulk of work for select. Fetches are only performed for select statements. Library cache information. Misses in library cache during parse. Indicates that number of times the statement was found, soft parse, or not found, hard parse, in the library cache. If it is 0 then it means soft parse happened as there was no miss. If it is 1 then it means one hard parse happened if there are a high number of parses per execution. This could indicate the lack of use of bind variables in SQL statements or poor cursor reuse. So our goal is that misses should be minimum or 0. Misses in library cache during execute. It means that number of times SQL text found but cursor not valid for reuse. Either object invalidation through DDL or different objects referenced /privileges, meaning a new child cursor must be spawned. Misses while about to execute the plan and founded missing /invalid in library cache. If no hard parse occurred during execute calls, that specific line is missing. Row source operation. From tabular statistics we can understand if there is any problem with the query, and then we can refer to row source operations to see what operations are costly. Row source operation is the actual execution plan written in the trace file by the server process. Under row source operation heading, first thing you will see is the operation type. Example: index range scan, nested loops, select, full table scan, etc. After that in the brackets you will find the I/O statistics like 11.2.0.2 provides 3 columns, rows, first, rows, average, and rows, max. Rows, first, number of rows returned by every row source operation, number of rows returned on the first execution. Rows, average, average number of rows returned for all execution. Rows, max, maximum number of rows returned for all executions. CR equals number of blocks read with logical reads in consistent mode. PR equals number of blocks read with physical reads from the disk. PW equals number of blocks written with physical writes to the disk. Time equals shows the cumulative elapsed time for the step and the steps that preceded it in microseconds, s1/1000000 of a second. Cost equals estimated cost of the operation used by the optimizer for internal comparison. Size equals estimated space usage of the operation in bytes. Card equals estimated cardinality, number of rows returned, of that particular operation. This information is very useful when looking for the point in an access path that takes all the time. By looking for the point at where the majority of the time originates, it is possible to narrow down a number of problems. These statistics can be useful in identifying steps that read or write a particularly large proportion of the overall data. Wait event information. We know if there is problem with a hint about the problem area from tabular statistics and the most costly operation from row source operation. Now we can get the details where this query is waiting from wait event information. This is another important section of TKPROF output file as it gives us the details on the wait events on which the query is waiting. We can use wait event information and link it to the theory deduced from tabular statistics to confirm the bottleneck of the query. From this information we can either try to reduce the cause for the waits or from row source information see if any other alternate access method can be used.